Hello everyone, hope you all are doing well. So today I am back with another Leetcode Daily Problem, and it is Leetcode number 1026, maximum difference between node and ancestor. Okay, so the question is, given the root of a binary tree, find the maximum value v for which there exist different nodes a and b, where v is equals to uh, a dot val minus b dot val, and A is an ancestor of B, and node A is an ancestor of B if either any child of A is equals to B or any child of A is an ancestor of B. Okay, so this is the example. I will explain it in my explanation section. Let's go through the constraint. The number of node in the tree is in the range from 2 to 500, 5000, sorry, and node value is from 0 to 10 to the power 5. Okay, so there exists a tree. Always there is always exist a tree, and it is a medium level question, and I also feel the same. Okay, so this is the first example, and the answer of this example you can see is 7. Okay, why it is 7, and what is the mean of ancestor? Okay, first of all, if you consider this node, this is the ancestor of this all node 3 1 6 4 7 and also 10 14 13. Okay, similarly the 3 is ancestor for 1 6 4 7. Okay, 10 is ancestor for 14 and 13. Means I hope you understood the this is the parent of this all, and this is the also parent for this all. Okay, similarly 6 is ancestor for 4 7 and 14 is for 13. Okay, so how we get 7 for this example? If you see carefully, uh, what we can take, look, like if we take this as ancestor, then these two equation is, you will get to be the maximum difference is 2, and these two the maximum difference is 1. Okay, now this is ancestor for this also, this also, this also, this also, but we have to maximize our score, so we will take the minimum element. Okay, so from the left the minimum is this one, so only one node is there, so this one, so it will give 2. And from this 3 element, how we can minimize maximize it, like if we do 6 minus 3, it is absolute value, so we can take either, or you just write it in an abs function. Okay, so 6 minus 3 is 3, we get a 3. And if we take this node, then it will 4 minus 3 1. And if you will take this node, then this 2 means 7 minus 3 is 4. Okay, similarly 13 minus 14 is 1. Then if we take this node, so it is 14 minus 10 is 4. And if take this two node, then its difference is 3. Okay, similarly for this all node can be child, and this all node can be child. So what we take now, once again we have to check for all the nodes. Then this is 3 minus 8, it is 5. Okay, then 8 minus 1, it is 7. Then 8 minus 6, 2. Then 8 minus 4, 4. Then 8 minus 7, 1. From this side, 8 minus 10, 2. 8 minus 14, 6. 8 minus 13, 5. Okay, it is absolute value. We have to take absolute value, so I only consider it as positive only. Okay, so you can see from all this, the maximum score we can get is 7. Okay, no other score is more than 7. So what this means, like this node and this node gives you 7. Okay, 8 and 1. So we have to find like this. So for this we need all the element from left and all the element from the right, but we cannot perform DFS for every node. Okay, so if we do so, it will be like it will be very high complexity and we will not able to get answer. We will of course get TLE. So what we will do, we just simply maintain a max variable and a mean variable. Okay, so we only just return the maximum element, okay, and the minimum element from left, and also maximum element and minimum element from the right also. Okay, now let me show you the code. Okay, so this is the code basically, or this is simply I just call this function. So this is the whole code. This is the function, solve function. Okay, I have taken a pair of integer. The first int will point to the minimum element, and then a second int will point to the maximum element. Okay, so what this do will, like I it is confirmed that there will at least two node. Okay, there will be at least two node as they has provided in the constant also. So I have not checked for if my first element is root or something. So I have just I have keep a pair. I have taken a pair and just put the root value and the minimum and maximum. If there is only one node, okay, let's say there is a node like 5 and it is a single node. Okay, and there is also node 1. Okay, for 5 this is a single node, so its minimum and maximum value is 5 itself. Okay, 5 comma 5, its minimum and maximum element. Now I check if its left exists. Okay, if a node does not have left child, like for example in this, um, you can, it is 10, you can see that there is no left child. Okay, no left child, so I will not call for this. And if there is no right child, like this example, then I will not call the right side. And also if it is a leaf node, it does not have any left or right, then we just simply return this value. Okay, this matlab, this means this value, the node value. Okay, so in the early stage we just store the node value and we just perform left and right if it is exist, if it exists. Okay, then we check if the current root value minus the value we get from left and the value we get from right, left for first and left second, means minimum and maximum from the left, then we perform an ABS subtraction, then we just maximize our answer. Okay, and we also check if the first, if the pr dot first means this node first is minimum or not. Okay, so if the left, if for example if this is a 10, okay, and its left is something like 2 and its right something like 3, then it here it will return 2 comma 2, means minimum is also 2, maximum is also 2, and from here it is written 3 comma 3. And when we after returning from here, we will perform this thing, and currently the pr value is 5 comma 5, minimum and maximum is 5 comma 5. But when we perform the left and we get 2 comma 2, we just check if, first we have to check if 5 minus 2 is greater than our current answer or not, and 5 minus 2 again is greater than, or greater than our answer is answer or not. Okay, means this is the minimum and this is the maximum. We have to minus from both minimum and maximum, as you can see I have wrote it here. Okay, then we have to update this value, like we need a minimum value in place in the here and a maximum value here, so we can compare this 5 and this 2, minimum with minimum, and this maximum with left's maximum. Okay, I just perform this same thing, then I call the right side, then I just check if right like 5 minus 3 is greater than our answer or not, so we have just simply maximize it. Okay, then I have check again this element here, after this it will update to something 2 comma 5. So after updating we just check 3 and 2 and 5 and 3. Okay, so 3 and 2, and we need here minimum, so it will not change, and 3 and 5 we need the maximum, so it will again not change. So our final pair is 2 and 5. Okay, so and we return here, from here to here we return 2 and 5. Now now we just again check for the same, like we just check 10 minus 2 and 10 minus 5. So you can see before here it is 10 comma 10. Okay, after checking our answer get updated to here, our answer is maximum we can get here is 3. Okay, but here we can maximum get is 10 minus 2, and it is 8. Okay, so after that we just simply update this, like this is the minimum one, so we'll minimize, and this is 10 is maximum, so we get 2 comma 10. We just simply return from here also. Okay, but there is no node above, so our this function will get executed completely, and our answer is 8. So you can see that this minus this is the maximum, 10 minus 2 is the maximum, and we also get the same. Okay, so this is the whole approach, and it is a pretty simple code, not that much complex. Okay, so and finally I just return the answer variable. So let's run the code. Okay, so this is the code. Let me submit. Okay, submitted. So I will provide the question link and my solution link in the description box, so you can check out if you need. So enjoy the 31st night and stay safe at home, and see you tomorrow. Goodbye. Thank you.